Okay, in lesson 19, we're still exploring quadrilaterals. Okay, I know they have question 1 done for us, but I think there's some problems with it, so I'm going to go over it. First says A, draw a kite that is not a parallelogram on grid paper. Now, the one they had on my copy online was actually a regular quadrilateral, and it would not be classified as a kite because kites have specific properties. So I went ahead and I've inserted a picture of an actual kite. Okay. Now, let's go through these properties. Four-sided, yes. It has to be four-sided because it has to be a quadrilateral. So it definitely has to have that. Next says 2 consecutive sides are of equal length. And it's basically saying this side and this side are of equal length. And that is true. When you say consecutive sides, adjacent sides, it just means the 2 on top are of equal length. Next one says 2 remaining sides are of equal length. And that's true. This side and this side are equal length. Now, next thing says pairs of angles equal 180. That's not always true. On some kites, it would be true. Okay, and we'll get into that in a minute, but this is not always true right here. Pairs of angles are not. Now, if it's a parallelogram, if it's a rectangle, if it's a square, if it's a rhombus, that would be true. Okay, and we can get into that, but an actual kite, the pairs of angles do not equal 180. Because if you look at here, angle D plus angle A is not going to equal 180. It's actually going to equal like 206, 207 degrees. And the same thing, if I added D and B, I ended up at 214.2 degrees. So there's no 2 angles that I could add together for a regular kite and get 180 degrees. But what it does show me is that the 2 opposite angles, such as D and B, will be equal. Okay. A and C will not be equal unless specific things apply, and that's what I'm going to get into down below here. It says, when can a parallelogram also be called a kite? Well, that would be if our kite was actually a rhombus. Now, if it would be a rhombus, that means that this side would be equal to this side would be equal to this side. Okay, and that would be, since a rhombus is also a parallelogram. So a parallelogram can be a kite when the figure is a rhombus. Now, if it was a parallelogram or rhombus as a kite, then this pairs of angles would be equal to 180, would be true again. But that's not really a property of a kite. It's a property of a rhombus or parallelogram. Okay? All right. I hope I cleared that one up. Let's go to the next one. Let me get this out of the way so I can see. It says, if rectangles have right angles, explain how a rhombus could also be called a rectangle. Well, first off, let's draw a square. Now, if I were to turn that square on its side, now most of you would say that was a rhombus, except for the lines aren't exactly straight, but I'm trying to freehand it. Okay, so it says if rectangles have right angles, explain how rhombus. So basically, if the rhombus was a square, then the rhombus would also be a rectangle, because all squares are rectangles. Number 3, draw a rhombus that is also a rectangle. So just like I said, we're going to have to draw a rhombus that is a square. So I'm going to come down 3, and I'm going to try to come straight across and come up, over, and down. So now this here is a square. The square can also be a rhombus. And since it's a square, since a rhombus is a square, then it would also be a rectangle. Kirkland says that the figure EFGH below is a quadrilateral because it has 4 points in the same plane and 4 segments with no 3 endpoints collinear. Explain his error. Well, his error is right here. Has intersecting points. So in all actuality, instead of a quadrilateral, it actually has 2 triangles. Because as you can see, EF in this unknown point would be one rectangle. H, the unknown, and G would be another one. So even though they've used 4 line segments, that intersecting point right here creates a vertice, which would be another point. So we would actually have